Okay, in this video that we're looking at today we're looking at the Sine Rule. In particular, we're looking at the ambiguous case. How do we know when it's an ambiguous case? So, as we know, for the Sine Rule, involved in the question is two angles and two sides. So, if we're given two angles in our information, then the geometry of the triangle's pretty much set, because we also know that the angles inside a triangle add up to 180. So if we've got two of them, we can find the third one very easily, and so it's not an issue. The ambiguity or uncertainty in what the triangle might look like arises in a certain situation, and so when we're finding an angle, so when we use it to find an angle, but not in all triangles, only in some of them. And so here's some conditions or some measurements, constraints, whatever you want to view them, where this ambiguous case, as it's called, i.e. uncertainty in what the geometry of the triangle is, occurs. So it occurs when we're given one angle and two sides. So we've been given one angle, we've been given two side lengths, and we've got to find the other. Now there's some further geometrical conditions, if you like, on that. So one of those two sides that we've been given is opposite the angle, and it's also shorter than the other given side. So here's an example here where that might be the case. So we've got the angle at A is 30 degrees. We've got the side opposite A is 5 centimeters, and then the other side is 9 centimeters. All right, so this one is shorter than that one. All right, so, and then find the angle. Okay, so let's have a look. What would this look like? So if I make A here, so there's my vertex A, and I've got to make an angle. So let's make an angle. I'll make an angle out of dotted lines, and then I'll fill them in later. So this angle in here, between those dotted lines, and I'm going to draw those in a minute and how long they would be. And then vertex B is over here somewhere, and vertex C is up here somewhere. And so here, this 9, side length 9, that's opposite vertex B, so that's this here is 9. It's 9 centimeters. Now this A here is 5 centimeters. So that's this length here, 5 centimeters. So it's got to then reach down to this dotted line. All right, remember I just used dotted lines to make the angle, and now I'm filling in the lengths. But this 5 has got to reach down. So the question is though, how does it reach down? Does it reach down over there, or does it reach down over here? That's the question. And so I've got this animation here, and I've got my triangle drawn. There's my angle of 30, there's my side length B, and here's this line here, length 5, and see it's swinging around, and so it touches that dotted line that I did. It touches in two places. So you can see that that's the case. So sometimes it touches in two places. Now if it's too short, of course, you don't get a triangle. So there's a limit to how much shorter it can be, but as you can see, it's where there's two possibilities, and so that's what we refer to as the ambiguity or the uncertainty as to what the geometry of that triangle might be. So we end up with two possibilities, and that's what I talked about. You know, what are the two possibilities? What does it? This 9, here's our 30. Does it look like this? That's 5, so that's the one out here. Or when we swing around, does it go down there? So, or is it the geometry of that triangle? Is it like that? All right, because both of those triangles, that's our C up here, of course, both of those triangles fit the information that we've been given about the triangles. So geometrically, both of those triangles fit all this information up here. But quite clearly, the angle at B here and here, quite clearly they're different. All right, so that's the ambiguous case. Now, if this side is longer than that one, so if, for example, I'll just point this out, if, for example, we had angle A still 30, side length A, say this time was 12, and side length B was still 9, and so again, when we do this time, our dotted lines to make our 30 degrees, there's our A, B's down here somewhere, that side there, that one's the 9. Now, because this now is 12, well, 12 is longer than the 9, so it's not actually going to, if we have it swinging around, it's not actually going to swing past the bottom, isn't it? So the only way now that we can get a 12 that crosses that line that creates our angle of 30 is for that to be out here. All right, so then there's side length. So that's what this triangle looks like. All right, so up the top here, when I said this, that the side opposite, that's this, the angle given, it's got to be shorter than this other one. All right, so that's how you would kind of determine. So these are the things that we're looking at. I haven't actually solved the triangle there and how you actually get these two angles, how big they are. There's plenty of videos out there about how that you can do that. This is really, it's just talking about how you would identify as to whether the ambiguous case is occurring or whether it's not. All right, so the ambiguous case, essentially what it means is that we're uncertain, we're not sure what the actual geometry of the triangle is, because there's two possibilities that could fit into the information that we're given, and this is the properties of that information that you're given. All right, so you still need some more help with that. There's plenty of YouTubes that you can look at that explain, so someone else might explain it differently to me, and that might resonate with you. And of course, you're doing maths, so I know you're having fun.